Tonight, you set your alarm for exactly 7 a.m., you close your eyes, you disappear for 8 hours. Then something strange happens. At 6:58, your eyes open. The room is silent, your alarm has not rung, but somehow your body seems to know. 2 minutes later, the alarm screams, and now you are staring at it, because this has happened before, maybe 5 minutes early, maybe 30 seconds early, sometimes almost exactly on time. So how did a sleeping brain read a clock? The short answer is that it probably did not. The stranger answer is that your body contains its own clock, and it has been running since before alarm clocks existed. Deep inside your brain sits the suprachiasmatic nucleus. Scientists usually call it the SCN. It contains roughly 20,000 neurons. Together, they help coordinate your circadian rhythms. These rhythms follow a cycle close to 24 hours. They influence sleep, body temperature, hormones, hunger, alertness, even when you feel mentally sharp. But your internal clock is not perfectly isolated. Every morning, light enters your eyes. Special retinal cells detect that light. They send timing information toward the SCN. The brain uses this signal to adjust its daily schedule. This is called entrainment. Sunlight is one of its strongest signals, but behavior matters too. Meals happen at certain times. Work begins at certain times. You exercise at certain times. And perhaps most importantly, you wake repeatedly at similar times. Your body loves patterns. Give it enough repetition, and tomorrow stops being completely unpredictable. Imagine waking at 7 o'clock every weekday, Monday, Tuesday, Wednesday, again and again. Your alarm thinks it is training you, but something else may be learning the schedule. Before you wake, your sleeping body is already changing. Body temperature begins shifting. Sleep becomes lighter near morning. Hormonal activity changes. The brain moves through repeating sleep stages, and systems supporting wakefulness begin preparing for daytime. One famous hormone in this story is cortisol. Most people know cortisol as a stress hormone. That description is incomplete. Cortisol also participates in your daily biological rhythm. Its levels typically rise toward the biological morning. Researchers have studied a phenomenon called the cortisol awakening response. Cortisol often rises around the transition into morning wakefulness, but the exact relationship is more complicated than internet myths suggest. Your body does not simply fire a magical cortisol alarm. Circadian timing, sleep, anticipation, and awakening interact. In 1999, researcher Jan Born and colleagues tested something remarkable. Participants were told when they would be awakened. Some expected an early awakening, others expected a later one. The researchers measured ACTH, a hormone connected to cortisol regulation. The early waking group showed a stronger anticipatory hormonal rise. Their bodies appeared to prepare for the expected awakening. The participants were still asleep. Think about that. A conscious expectation had been created before sleep. Hours later, the sleeping body behaved differently. So what exactly remembered the appointment? There is no tiny clock inside your skull. No neuron checks a digital display at 6:59. Instead, the brain tracks biological time through changing internal states. Your body is less like a stopwatch. It is more like an orchestra. Thousands of processes rise and fall together. Temperature changes, hormones pulse, neurons alter their activity, sleep pressure declines, light-sensitive systems wait for morning. And when these rhythms become predictable, waking can become predictable too. This helps explain why consistency matters. If you wake at wildly different times, prediction becomes harder. If you sleep until noon on Saturday, your rhythm shifts. If you fly across 8 time zones, the clock becomes confused. Your watch changes instantly, your biology does not. That mismatch is jet lag. And it reveals something important. Clock time is invented. Biological time is not. Humans divided days into hours, then minutes, then seconds. Your cells never agreed to those units. They respond to cycles, light and darkness, activity and rest, eating and fasting, temperature rising and falling. So when you wake at 6:58 before a 7 o'clock alarm, your body may not know 6:58. It may know something more ancient. Morning is approaching, sleep pressure has fallen, the circadian system is promoting wakefulness. This is usually when we rise. And today, something important is expected. But there is another possibility, one that makes the experience less supernatural. You may wake before your alarm more often than you remember. Imagine briefly waking at 4:17. You turn over, you forget it. Then you wake at 5:43. Again, you forget. But when you wake at 6:58 and see your alarm, that memory survives because the coincidence feels meaningful. Human memory is not a security camera. It selects, it compresses, it forgets. We notice successful predictions, we often ignore failed ones. So some perfectly timed awakenings may be biology, some may be coincidence, and some may be remembered because they were strange. But repetition can make the effect more believable. A stable wake schedule strengthens predictable timing cues. Morning light reinforces the circadian system. Regular routines reduce uncertainty. The body begins preparing before consciousness returns. And then there are high-stakes mornings, a flight at 5 o'clock, an important examination, a job interview, the first day of a new life. You set 3 alarms, you check them twice, then you wake before all of them. Why? Anticipation changes sleep. Stress can make sleep lighter or more fragmented. The importance of waking may influence your physiology. Your brain does not completely disconnect from tomorrow. Sleep is not an off switch, it is an active biological state. The brain continues monitoring, processing, regulating, predicting. Even external information can sometimes influence sleeping brains. A sudden sound may wake you. A familiar voice may become important. A parent can sleep through traffic, then wake to a child. The sleeping brain is not unconscious in the simplest sense. It is selectively disconnected. The gate is lowered, but the city behind it is still working. And this raises a stranger question. If part of you can prepare to wake before you are awake, where exactly are you? We often imagine consciousness as the boss, the central controller, the person giving orders. But most of your body does not wait for conscious permission. Your heart beats, your lungs breathe, your liver manages chemistry, your immune system patrols, your brain predicts. Then consciousness arrives and receives the result. You open your eyes at 6:58, and it feels like you performed a trick. But the work began before you were there to witness it. This does not mean everyone can reliably wake without an alarm. Do not test this before an international flight. Sleep schedules vary. Circadian rhythms vary. Sleep deprivation changes everything. Shift work can disrupt normal timing. Illness, stress, medication, age, and light exposure can alter sleep. And researchers are still debating important details of morning hormone dynamics. The science is more complicated than one hormone and one internal stopwatch. But the central idea remains extraordinary. Your body is constantly estimating what comes next. Evolution built biological timing long before mechanical clocks. Organisms had to anticipate sunrise, temperature, food, predators, movement, rest. A creature that only reacted after change had already happened was always late. Prediction was useful, so life learned rhythm. Eventually, one species invented clocks, then schedules, then meetings, then alarms. And now, every morning, ancient biology negotiates with a rectangle beside your bed. Sometimes the rectangle wins, sometimes you hit snooze, and sometimes, 2 minutes before it makes a sound, your eyes simply open. Not because your sleeping brain secretly read the numbers, but because the numbers were never the deepest clock in the room. You were.